Hi everyone, this lesson is about using the unit circle to calculate trig ratios, sine, cosine and tan. So a couple of quick things to have for reference. These are things that we need to remember. We need to remember that 180 degrees is equivalent to pi radians. So that's a fact that we just have to remember. Previous videos I've explained why. We also need to remember that when we're using angles beyond 90 degrees, the quadrants, the first, second, third quadrant, it's the following trig ratios are positives. So in the first quadrant up here, remember this is the first quadrant, all trig ratios are positive. Sine is positive in the second quadrant, tan in the third, and cosine in the fourth quadrant. The other thing I suppose we need to remember is that we always refer to a reference angle in relation to the x-axis. I'm going to highlight the x-axis. Our reference angles are always in relation to the x-axis, an acute angle. Let's try a few examples. I think you'll pick it up as we go along. So here's one. What if I had a question like sine, and it says pi plus alpha. Alpha is an acute angle. So I'll first draw myself a little diagram. I'll mark in, that's where 0 lives. This is pi. I have pi plus an acute angle, so I'm talking about a bit further around, pi plus alpha. This is the reference angle alpha. Now, sine of pi plus alpha will numerically equal the same as the sine of the reference angle. Now I have to decide whether it's positive or negative. In the third quadrant down here, tan is positive, sine will be negative. So the answer to this one is literally done by looking at the diagram, deciding what the reference angle is. Remember, the reference angle is always in relation to the x-axis. The actual angle of sine plus alpha would travel all the way around that amount there. That's our first one. Let's try one with some numbers now. What if I had, here's a good question, find the exact value of cosine 120 degrees. Draw yourself a quick sketch. Mark in where 0 lives. We're in degrees this time, so this is 180 degrees. This is 90 degrees. Now 120 is closer to 90 than here, so it doesn't have to be a perfectly accurate diagram. That's 120 degrees. 120 degrees measures from the positive x-axis around to there. I'm interested in this small reference angle here. The reference angle is always in relation to the x-axis. I hope you can see, just by simple deduction, 180 minus 120, that would be a 60 degree angle sitting in there. So the cosine of 120 will be equal to the cosine of 60 degrees, numerically equal. Now I decide if it's positive or negative. Remember our little rule, all stations to central. The sine is positive over in this quadrant, that means cosine is negative. So the cosine of 120 will equal negative cosine of 60. Now I need to remember my two special triangles. I said you just need to remember those. Sorry, I lied. I didn't lie, I forgot. I forgot that we need two special triangles. With a right angle triangle with unit side and unit height, that would be a 45 degree, and that would be root 2. And then, and I always remember that one by remembering that tan 45 equaled 1. Then I have a different one. This is the 30-60 degree triangle, and I always remembered that sine 30 equaled a half. So if sine 30 equals a half, opposite must be 1 and hypotenuse must be 2. Pythagoras will quickly tell us that the base then is root 3. So I needed down here the cosine of 60 degrees. So cosine of 60 is adjacent over hypotenuse. That's 1 over 2. So this is negative 1 over 2. That is the exact answer for the cosine of 120 degrees. Let's try another one. Let's go something with radians this time for our last one. Let's go the sine of 13 pi over 6. Oh, that's beyond. Oh, we can do this. That's all right. 13 pi over 6. This is going to be a bit of a weird one, but we can figure it out. Now, draw a diagram. Always do a diagram. Mark in 0, mark in, we're in radians this time, we'll mark in pi. Now, the denominator says 6, pi divided by 6. So I would sort of mark off here 1, 2, 3 steps, 4 steps, 5 steps. By the time we get to pi, that's 6, 7, 8, 9, 10, 11, 12, 13. I have gone all the way round and then an extra one. 13 pi over 6 is here. Now that's a little bit of a mean one because it's greater than 2 pi, isn't it? So it's a full rotation plus an extra piece of an angle. Again, the reference angle is always in relation to the horizontal axis. My little reference angle in here is going to be, oops, pi over 6. That angle there is pi over 6. So the sine of 13 pi over 6 is the same numerical value as the sine of the reference angle. Now I need to decide if it's positive or negative. Remember, it's all stations to central. All trig ratios are positive in this corner, in this quadrant, so it is literally sine of pi over 6. If I go back to here, remember pi over 6 is the same as 30 degrees. Sine of pi over 6, well, that's 1 over 2. That's the one that we remember. So this is 1/2. The sine of 13 pi over 6 is 1/2. That's a quick little refresher on how to find the sine, cosine or tan of any angle at all. So it doesn't have to be acute. We use reference angles. We remember those little fun facts at the top of the page. If we remember these and we follow that procedure, we will always get these right. Thanks for watching.